Welcome to day 2 of the Millennium Innovation Forum, to all of you here in the Congress Center, to everyone joining online. You're all very welcome indeed. Now, yesterday we kicked off the forum with some incisive words from Prime Minister Sanna Marin and a fascinating session on diversity in research, development, and innovation. And of course, we saw the crowning of the 2022 Millennium Technology Prize winner. Now, today we have really quite a lot to get through. Again, 3 more sessions on the green transition, on digital transformation, and on resilience. We'll have the handing out of another prize, and we'll hear from our new Millennium Technology Prize winner in a lecture. But again, as yesterday, don't worry, there are lots of breaks for networking, for chatting, for digesting ideas and ingesting caffeine. The first session of today, the second session of the forum, is of course very connected to the theme of the prize this year. And I was thinking about the tagline of the forum, Innovations for a Better Life. I was saying yesterday that there's a very long line between the germ of an idea and the better lives that might result from it. And I was thinking that our prize winner, Professor Martin Green, his story kind of shows you that whole line, from a kind of, how could this be improved, to an improved technology, to a technology that is now improving, as he said, hundreds of millions of lives. But he also told a story last night about how researchers from his group went on to basically form the seed of China's solar industry. That, in turn, drove a lot of American investment and investment from elsewhere into Chinese companies. And as we know, China is now the center of the global solar cell manufacturing industry. So this story that starts with these tiny little electrons and tiny little holes grows to have implications in global business, in its way in geopolitics. That's a great story of how what scientists and innovators do can grow very, very far indeed. Now, there's an aphorism, there's a saying in English, which is, mighty oaks from little acorns grow. I think this is an encouraging story, encouraging tale, perhaps even a cautionary tale. If you build into what you're doing the elements of what we're talking about here at the forum, the green transition, diversity, resilience, it can have effects that stretch far beyond what goes into your startup pitch or your grant proposal or your government manifesto. So it's worth thinking about all of these topics, even when all you've got is that acorn. To take us through then into the green transition session, I would like to introduce you to your chair, who is an atmospheric scientist and a chancellor at the University of Helsinki. Please welcome to the stage Professor Kaarle Hämeri.
Good morning, everybody here on the lecture hall, and you who are following this online. It is a great pleasure for me to chair this session on green transition, where we have some subtitles as what kind of disruptions are necessary for the green transition, what impact can technology make to mitigate climate change. Today we have 4 specialists from different angles of green transition, giving a 10-minute introductory talk first, and then we follow that by panel discussion. And please, you in the audience, if you have any questions, also in between the panel discussion, just raise your hand and I'll try to catch also comments and questions from the audience. I will leave some room for that at the very end. But my pleasure is to introduce you first, the first speaker of this morning, who is Professor Markku Kulmala. He's academician, working as a professor of Aerosol and Environmental Physics at the University of Helsinki. Markku Kulmala is ISI highly cited researcher and world's most cited scientist in geosciences for many years. He is also an ERC Advanced Grant holder and a leader of INAR and ACCC flagship. In addition, Kulmala is a winner of more than 10 international awards. He has memberships in 8 academies and has 9 honorary doctoral degrees and professorships. During his career, Kulmala has made around 1,200 publications. The main focus of his research team has been the formation and growth mechanisms of atmospheric aerosols, dynamics of aerosols, air ions and clusters, air, cloud, climate interactions, relationships between the atmosphere and different types of land surfaces and climate. In other words, air quality interactions. His presentation title is Climate Change, Air Quality and COVID, on the importance of comprehensive observations. So please join me welcoming Professor Markku Kulmala on stage.
Thank you, Kaarle. Ladies and gentlemen, as everybody knows, we have only one planet. And what do we need? We need, of course, good social environment, but we need also good food, fresh water, fresh air, energy. But what do we get? We get air pollution, we get changing climate, we get biodiversity losses, some challenges in water and food supply, energy supply, acidification, deforestation, pandemics, wars, etc. And all these items, challenges, are interlinked. We cannot, in principle, solve them one by one. That's why we need to understand this complex picture. We need all disciplines. We need science diplomacy, we need observations, we need actually work from ideas to implementation. And the basic thing is, of course, that when we look at this system, world population is increasing. Of course, 2020 is values which we know. Then also global gross-domestic production is increasing and energy use is increasing. And all these things makes us, let's say, the system complex enough to solve. And that's why we need big data. But let's show one small thing. Today, almost everyone is speaking about carbon neutrality. It means that carbon CO2 sources should be smaller than sinks. And sinks are, for example, that we take CO2 technologically out from the atmosphere, or we use forest or agriculture or whatever. The more or less biospheric sinks. And here is one point. If we start to decrease emissions 2% per year and enhance continental sinks 2% per year, after 23 years we are carbon neutral. But although I have here 2020, starting 2020, but actually today, every year, this CO2, atmospheric CO2 concentration is increasing 2 to 4 ppm, part per million, every year. We do not see any decrease in this concentration today. We even do not see, okay, during COVID year, we saw globally 7% decrease on the emissions. But still, concentrations were increasing. And it's not, of course, a surprise. We are comparing numbers 40, which is this annual emissions, 40 gigaton CO2 per year, and sinks are about 20 gigatons. And if we think about errors in all those measurements and calculations, this is natural that it's increasing. I am that optimistic that I still believe that before I get too old, I will see that this goes down, this CO2 concentration, these annual values. Maybe I'm too optimistic, but hopefully not. And we can really measure these carbon sinks. We can measure it. And if you speak about compensation, which is other important word today, if we want to compensate something, we need first to measure. We need to know that it's really taking out this CO2. And for example, this place where we are measuring it is our station in Hyytiläsmäär 2 station. We are able to measure exactly which part of CO2 goes to soil, which via photosynthesis to needles and stem. And it's about 200-250 grams per carbon per year per square meter what we get. And this is the place where we are making those measurements, observations. And we are actually observing more than 1,200 different variables. And why? With this kind of comprehensive long-term data set, we are able to answer questions what does not exist today. Also future questions. And we certainly will have future questions. Scientific questions, technical questions, socio-ethical questions, economic questions. And with big data set, we are able to do this. But of course, CO2 is not the only one, and that's why we are measuring more than 1,000 different variables. If we think IPCC, Intergovernmental Panel of Climate Change, we still see that current knowledge, current observations is fragmented. And this what we have in Finland is still exceptional. We have in a couple of other places all around the world those. But we need to observe at the same time greenhouse gases, aerosols, air quality, ecosystems, climate, etc. in the same places and in comprehensive way, and at least to use the data openly enough. And besides this CO2 carbon sink, if we take the total effect of, for example, our boreal forest to atmosphere, the total effect is 20 to 80% more than the carbon sink alone. And I'm calling it carbon sink plus, which takes into account volatile organic compounds, aerosol particles, clouds, precipitation, albedo effects. And this is what we call SMART concept, that we are able really to observe very, very many different things. And the concept itself, we have already seen that it's very effective. We are able to see insights, for example, in COVID restrictions. We have very good observations in Beijing right now. And this is related to this Chinese air pollution cocktail. And we also want to build up a global observatory, which means that in principle to answer all those global challenges, to get this open data, we need different ecosystems, different surfaces, urban, big cities, megacities, cryospheric things, forest, peatland, lakes, oceans, etc. And besides COVID, for example, when there was this Icelandic volcano eruptions, we were able to do it. Different accidents can be seen very, very, very well. Terrorism, war, etc. Since we have signals of those things, what we can observe, which is very important. One example is that, for example, when there was this Nord Stream 1 and 2 accidents, or whatever we call it, we are able to see what comes out there in different stations. And all these things are, of course, important. And actually, we can find new mechanisms and feedback loops, understand what happens in the atmosphere, understand what happens globally. And policymakers can test their policies with this kind of data, and companies can make new services, climate services, environmental services, and other services. And since I have started my career as a theoretical physicist, I need to give one equation in all my presentations nowadays. And this should not be too difficult equation. The point is that in a climate point of view, and really to save the planet, we need to do something. But always when we want to do something, there is the resistance. And to go over the resistance, we need first you understanding what we want to do. Then we vision what to do. Then capacity or roadmap or these kind of resources to do it. And of course also feasible plans to go over that. And actually if one of those is zero, we can never go over resistance. That's why we need all these kind of things to work with. And my dear friend, our chairman Kaarle Hämeri says that I cannot use more than 10 minutes, and he was very worried yesterday, and now I have till 55 seconds left. Thank you.
Thank you, Markku. You are absolutely right. It's my biggest duty to keep the schedule as it is written, and therefore I'm here. But we go on. This session is a mix of different perspectives to the green transition. We started to think about this global big picture of what is the globe, climate, and the big systems. But we go towards the technology and towards the solutions. And the next one to present is Morten Wierod. He is president of the electrification business area of ABB since April 2022. He joined ABB's executive committee back in April 2019 when he became president of the motion business area. Mr. Wierod joined ABB in 1998 as area sales manager, automation products in Norway, and has held numerous management positions in Norway and later in China. In 2011, he was appointed managing director of business unit control products in ABB's low voltage production division, followed by his appointment in 2015 as managing director of business unit drives in the robotics and motion division. Mr. Wierod graduated from Norwegian University of Science and Technology in Trondheim and holds a degree in electrical engineering. So, Mr. Wierod is giving a presentation titled Innovation and Technology are Key to Delivering a Green Transition that Balances Social and Economic Progress. Join me welcoming Mr. Wierod on stage.
Thank you, and warm welcome to everybody from my side as well. And it's great to be here talking about the green transition and how we can use technology and making that happen. But let me first start also with congratulating the Professor Martin Green for his Millennium Technology Award that he has received as a pioneer and as a leader in the solar industry and in the field of solar and how we can use that technology. So well deserved. It's something who is passionate around the green transition, as I am as well, on making the world going electric in a more in a safe and smart and sustainable way is one of the topics I want to talk about. But let's go first also to looking about where we are today. And we have talked over the last 20 years about the risk of climate change, what may happen. And I think the last years have shown that those risks we have talked about is really happening. It's the drought we've seen on 3 continents this summer, followed by flooding, followed by hurricanes that was used to coming every 5 to 6, 7 years, which now happens every year. So it's it's a backdrop which is scary, and I hope you all share that same understanding as well, that the risk we talked about is happening, and therefore there is a time for change. And that is why we have to act now and cannot wait for the future to see if it gets better or if it gets worse. We cannot take that chance anymore. And how do we make that transition happening? It's very much about using technology, and one of them that I am in the midst of, and as we as ABB as a company is in the midst of, is the part of electrification. And I believe that one of the parts and one of the solutions to the challenges we face is that the world needs to go electric. And we are going electric, as we see that in the field of having more sustainable transportation, where diesel trains be replaced with electric. We are driving more electric cars, for example, in the transportation, but it's not happening only there. So as we move on, we have to continue implementing more of renewable energy, like solar, and what Professor Green has been in the forefront of over the last more than 30 years. But we also need to invest more in the resilience and the stability of the power grid, because power and the network has not just become of national interest, like what the development what we've seen this year. It's even become national security item. So more renewable energy, but also a stronger and more resilient power grid. But finally, it's also one thing that we have to act on, and that's energy efficiency. Energy efficiency is one of these, let's say, simplest way of also reducing and making us a more sustainable. I think you all know that we're saying that the cleanest energy is the one that has never been used. And that is why energy efficiency is so close to what I work with and also close to my heart. So energy efficiency is no longer just an option, it's a must. And the good news is that energy efficiency is where we have already today the technology at hand. We don't need to wait for another 20 years to make it happen. It's already available today. And we can do so by using that technology. And I want to give a very practical example of how we do it. It's the escalators that we all use in the daily life. And in the past, those were running 24/7. And but then by using some more technology, of course, we installed sensors so that the escalators they only use when they're needed. So sensors or digital technology could easily reduce the impact of how we use it. Do you know, for instance, today, that everything more or less that moves is with electric motion, and 40% of the world's electricity is used by and consumed into motion by electric motors. And here also the opportunity lies that we have now much better technology available than what we had in the past. We're calling here in the industry for different energy efficiency levels. In the past, we used what we call IE1, then we moved to IE2. Today, IE3, 4, 5, and even 6 is what we are talking about. But still, most motors around the world today is used on a very low level on 1 and 2. So if we would move up the stack and take the new technology available and using that and implementing and upgrading facilities around the world, we could save up to 10% of the whole world's electricity. So that's a big opportunity that if we use technology at its best. But back to those escalators, there are of course also different ways what we could do is to add steps and stairs. It will require a bit of different behavior, also a different mindset to use the steps. Some would say going back. But I also believe that we have to think also to challenge ourselves on how we use energy and how we work. It is a change of mindset that is needed, and we can do that by educating and talking to people about making better choices. But here, I think it takes too long time to educate the whole globe on what is the right way and the right decision to make. So we need also here to use governments, policymakers, regulators, putting legislation in place that is driving that right behavior. So that is what is needed to work together as in both across industries, and that governments and regulators challenge us in industries as well. I know at ABB we are up for this challenge to use technology to drive the development. And there are some good news here, that we are seeing some of this change already. I used the example of electric motors. Here, the European Union put in place last summer new legislation that makes IE3, which was the third level of energy efficiency minimum standard. And next summer, we will move to IE4. Then you can say, well, but European Union in Europe, we cannot save the world alone. And it's true. But somebody have to take the first step. Because what happens when EU made the step of making this a minimum energy efficiency policy, China followed suit. They have already implemented the same standard as Europe. Saudi Arabia, the Emirates is now the next step. We as a company and our industry is working, of course, to get this also implemented in India and in the US so that the whole world moving in the same direction and have the minimum standard, raising the bar so we can save the energy and be better. We see the same in buildings, working on decarbonization of buildings, again, a common minimum standards that needs to be put in place. This is how we can use technology to also still having and using market power and the market setup that we know is working, but also using the technology, setting those minimum standards so we are able to get to a better place. And I say that it's not a one-man show. This is not one party alone that can do it. That's why we all have to work together to make this happen. That means also everybody coming together from the industries, on the customer, on the user sides, and also policymakers. And the only way is that we work together to make this happen. And I'm happy to see that that's kind of my firm belief is that electrification and that the world is going electric is one of the cornerstones and one of the things that can help us for a more sustainable future. So I hope you all join me in that statement that this is one part of the solution to a big problem we face. So let's electrify the world in a safe, smart, and a sustainable way, and we need to do it together. Thank you.
Thank you, Morten. This was very inspiring, and I believe that we all know that the world is going electric, and we see it in our near environment all the time. But, as they say, we don't have a silver bullet, at least not yet. The world is not simple enough to be solved by one solution. We need many solutions together, and we need to consider all the fields of technology to make the transition fast enough. One important part is naturally the fuels. How do we deal with the fuels in the future? What is the role of biofuels in our energy production? And we are happy to have Peter Lindfors to discuss about that. He is Senior Vice President in Innovation from Neste Company. He is the Chairman of the Board of the Fortum and Neste Foundation, co-chair of the Industrial Applications Roundtable European Clean Hydrogen Alliance nominated by EU Commission. He is a member of Perstorp Group Executive Team 2001 to 2007. He has over 33 years of industrial experience and 21 years in executive teams in large corporations. He has a broad experience in working with business-driven innovation, sustainability, and business transformation. Peter Lindfors received his Master of Science in Chemical Engineering from Chalmers University of Technology in Sweden in 1989. He received his doctoral degree with honors in the field of chemical reaction engineering from Åbo Academy, Finland in 1994, while working as a researcher in catalysis at Neste. He received his MBA from Henley, UK in 2005. Peter Lindfors will be giving a presentation titled Accelerating Green Transition, Role of Renewable Fuels. Please join me welcoming Mr. Lindfors to the stage.
So, distinguished guests, ladies and gentlemen, it's my pleasure to be here today with the other speakers to talk about the green transition and the bio and circular economy and the role of renewable fuels, with the case Neste as the starting point. Neste has transformed itself from a local oil refining company and marketing company into a global leader in circular and bioeconomy and renewable fuels. In the past 15 years, our market cap and profitability has increased with much more than 10 times. At the same time, the source of these profits has moved from 100% fossil to more than 90% renewables. We create solutions for combating climate change, and that's our purpose, to create a healthier planet for our children. We are accelerating the shift to circular economy. We are leading in renewable diesel and sustainable aviation fuels today. And we refine waste, residues, and innovative raw materials into renewable fuels and sustainable feedstock for plastics and other materials. Innovation has always been in the DNA of Neste. It has actually enabled this transformation through the innovation of the technology that enabled the conversion of glycerides into the high-performing hydrocarbon renewable fuels. And we strongly believe it is at the core of enabling Neste's future as we are on this journey in the field of renewable and circular solutions. Curiosity is a key point of innovation. And we have been curious and developing things for many decades already, and it's in the heritage of the company. And that is, I think, something which is very important when we talk about transformations and also the green transition, to develop the culture for innovation. And then, of course, on top of the curiosity, the capabilities. At Neste, we have roughly 5,500 people in the whole corporation. Out of these, more than 1,000 people are working with innovation. In engineering, in R&D, other fields. So we have actually a very strong brain pool with people experienced from doing new idea generation in the fume hoods or test tube scale to the people that are building the new plants. And when we combine these capabilities together, that creates the opportunity to transform. So curiosity, capabilities, and then of course cooperation. So on top of that, we need to have agile cooperation with our production units, our business units, and last but not least, of course, also with partners. The partner network becomes increasingly important as the challenges to transform become bigger. To keep it really simple, our one slider on this technology value chain of Neste is shown right now. It's a very simple concept, actually. In the 80s, we used Russian crude oil to convert it into high-value added gasoline components that we were able to profitably export to California from Porvoo refinery. So we used the low-quality crude oil to convert it into the highest quality products on the market through, of course, a high technology and innovation content. In the renewable field at the moment, we are using used cooking oils and animal fats, for instance, to convert them again into the highest quality products on the market, the renewable aviation fuels and the renewable road transportation fuels. And in the future, we will have the same philosophy, using circular economy waste like waste plastics, converting that into high quality solutions as one example. Now, of course, the challenge is immense, as we have heard, and we know that. Our existing feedstock base is not enough. we need, of course, to broaden the feedstock base. And what we are doing in innovation at the moment, we are really looking for scalable and sustainably preferred feedstock pools that we would be able, through high technology innovation content, to feasibly convert into the desired products in the road transportation, aviation, polymers and materials, and, as the question mark shows, hopefully also in the future, an even more diversified portfolio of businesses. This is a journey. So today we are working in the renewable oils and fats, the waste and residues there. But we see huge potential in several other openings, such as the algae, which of course is primary energy, taking carbon dioxide from the air, and through the photosynthesis we are able to get a product which is basically having both oil and proteins. Lignocellulosic waste and residues is a huge potential. More than 300 million tons of oil equivalent feedstock is accessible in terms of lignocellulosic waste and residues. Waste plastics, of course. Plastic is a fantastic material, but we need to take care of it. We need to take it out from the nature and recirculate it. And the waste plastic that cannot be mechanically circulated should be chemically circulated, and that's what we are dealing with here. Municipal solid waste is another example of a global huge problem going into landfills today. The organic part of municipal solid waste should be utilized and recirculated into high-value products. And of course, renewable hydrogen, or as I prefer to say, carbon-neutral hydrogen and power-to-liquid is of course another very interesting area for research. So we have a very broad portfolio and very exciting times, continuously striving for a broadened field of renewables and circular solutions for the world. And why are we doing this? I think everyone knows, but I have a slide just to illustrate a little bit the magnitude of this challenge. So this rectangular area shows the global oil consumption estimated in 2040. And this darker area of that rectangular is actually the estimation of oil, crude oil used in transportation in 2040. If we use all the available and foreseeable biofuel feedstock sources to convert them into biofuels, this green area would represent what we can achieve as a team of all companies in the world by 2040. So there is still quite a lot of black area left to be solved. And even with very optimistic estimates on electrification, it's not going to do the trick. It's an important part of a piece of the puzzle, but it's one part. So there is still more to do. And of course, renewable hydrogen or carbon-neutral hydrogen, power-to-liquid, and algae as examples are also there that can contribute to this puzzle. I still see this as an optimistic picture, though, as I think it shows that we are really, when we work together, as was said earlier in the previous presentation, we can do a lot of things. But the most important point for me is twofold. One is regulation should be such that it makes it easy to bring new solutions to the table. And the perfect striving for perfection is not good in regulation, rather for good solutions to get the things going. And secondly, there is not one silver bullet here, so we need to be embracing all of the different solutions. and really understand that there is not one way that we can solve this huge challenge. But I think there are excellent openings and good traction already, and I'm looking forward to very good development on the globe in the future. Thank you so much.
Thank you, Peter. So world is complex, but we have solutions. One thing we need to know when we are dealing with the new technology and the solutions to our issues and questions and problems is the impact of various actions. And this is what is the next talk about. We have Annu Nieminen, who is the CEO of Upright Project. She is the founder of and the CEO of Upright, a technology company building a new type of an AI-enabled quantification model to measure the net impact of companies. Upright's mission is to create concrete incentives for companies to optimize their net impact by enabling more fact-based decision-making for investors, customers, employees, and public sector agents. Upright's quantification model draws together masses of scientific publications and company-disclosed data to quantify both positive and negative impacts that companies have on their environment, health of people, society, and knowledge. Upright's open access data, impact data platform is currently used by more than 200 institutional investors and companies to track, report, and improve their net impact. Annu Nieminen has been chosen as an innovator under 35 by the MIT Technology Review and holds a Master of Science in Information Networks from Aalto University. Prior to founding Upright, Nieminen worked as a consultant at McKinsey & Company and as CEO of Finnish scale-up initiative Kasvuryhmä. She will give a presentation on title The Next Era of Impact Measuring. Please join me welcoming Annu Nieminen on stage.
Good morning, and thank you, Kaarle, for the intro. So my name is Annu. I'm an engineer, and my passion is bringing science-based rigor and understanding to how companies actually impact the world around us. We heard great introductions from my fellow panelists before on what the industry is doing, on what the science really looks like when it comes to the problems that we are facing. I'm going to take a very practical take into what all of this means for companies and how is the game very concretely changing for companies in terms of communicating, measuring, and understanding what is big and what is not. If you're leading a company or actually any other third sector or public sector organization in 2022, which I believe many of you are, it is not easy to navigate the jungle of impact measuring and what is sometimes called sustainability communications. My passion has to do with bringing the same kind of mathematical and analytical rigor to impact data that we are used to seeing in financial data. It shouldn't be that hard. When you hear people saying that, but it depends on so many things, this is the most complex problem I've ever tried to solve, but it is a very bad excuse for not trying to solve it at all. To bring scientific understanding to actual products and services and actual companies. But I'm going to start today with just trying to bring together from the discussions that I've had in the past 5-6 years with companies and investors in terms of what is concretely changing for companies when it comes to what is required from them in impact measuring. And this change is pretty huge, which I believe many of you know. So 5 years ago, this didn't almost exist. What was needed from companies in terms of impact, you talked a little bit about taxes and jobs, maybe a little bit of something about emissions if you were a really advanced company. And then, of course, there's been a lot of great work to be done internally in many companies. But when it comes to what you publicly disclose to the outside world, even if you have been publishing a sustainability report for quite many years, it still hasn't yet been something that you are really held accountable for example, in the board or in the executive team. And this is all changing, not just because of the demands of the private sector, but as you very well probably know, because of the regulations that especially the EU is now pushing. So what is concretely changing? Summarizing it to 4 concrete changes. The first one is that about 5 years ago, it was still completely enough just to describe what is being done, the process of what is being done to measure and kind of like manage sustainability. Nowadays, it is not enough. You need to talk about the science-based impact, both positive and negative impacts, that your core business has on the surrounding world. Where does the money come in, and how does that impact the world around you? And this is actually very common sense if you think about it. Let's take another example from the financial world that I like to use to compare. If a company told you, was like looking for funding from you and told you that, hey, we just started to do budgeting, that doesn't yet tell anything about the profitability of the company. It can be a leading indicator, it can be a tool, but a company saying that we have now started to track our something about sustainability, we have signed this compact, we have done this and that, it's not yet enough. You have to talk about what is the science-based impact today, and where will it be if we reach these and these targets. The second requirement for companies has to do with understanding that in 2022, no company can afford to think that they are an island. What does this mean very concretely? This means that you need to understand your end-to-end value chain that you are a part of. Not just your immediate suppliers, your immediate customers, and even that is a big challenge, I know. But you have to understand what is the value chain that you're a part of. To give you a crude example, if you are Apple, you cannot just look at like, yeah, we just do these nice devices, but the mining industry, oh, those emissions. The mining industry exists because of the further parts of the value chain, such as Apple or some other companies that are using the minerals and metals to actually produce products that consumers then buy. Another example from some of the recent discussions I've been having was with mobile gaming. I was talking with a couple of entrepreneurs and people working in mobile gaming, and they were like, we're really planning to go to net zero, and this is actually relatively easy for us, but hey, we really don't want to be those guys in mobile devices. They have it really badly. If you have a product that cannot be used without another product, you cannot think that the other product's emissions or impacts wouldn't be your business, or wouldn't be something you have to worry about. This is simply not adequate thinking in 2022. So you have to understand what is the value chain. How can you impact the value chain? Not just what happens inside your own facilities, under your own roof, but in the entire chain. Thirdly, and this is actually also an opportunity, not just a requirement, quantitative evidence on also the positive impacts you have. Not just telling stories, it's not efficient enough. You need to be able to tell what part of problem X are we realistically solving with this solution? What about the whole industry? We heard some good examples. What if the whole industry does X, Y, and Z? What does it actually change? And finally, and this is a very important people point on this is not something that can be tackled by your sustainability team alone. This is not something the company does what it does, and then the sustainability team is there to talk about it, or maybe tweak some incremental things about how it is done. If the company's board and executive team are not leading its impact, it's not being managed or led at all. And this is I think this is a message that many forerunner companies have already taken quite seriously in the past, and I've seen actually many moves already in the past like 12 months, and I think this change is about to accelerate a lot. Good. Well, how to address them? And very concretely, we have been talking about, and we will be talking a lot about CO2 emissions today, and for a good reason. They cannot be ignored, and they are definitely, if not the most important impact category, at least under any logic in the top 3 impact categories. However, I want to make a strong point why emission calculations alone are not enough. Let's take a very simple example. Let's say 2 companies. Let's assume we put together really robust quantification mechanisms. We calculate both of their emissions, and turns out that the CO2 equivalent emissions are X tons. So they produce the same amount of emissions. under the same logic of calculation. But for one of them, the product is a sugar-sweetened soda that is marketed for kids. And for the other one, it's a type 2 diabetes treatment program for the same target group. So very, very naive, simple example, but one of them is basically trying to fix the problem that the other one is a part of, at least partly causing. We need to understand other impact categories as well. Even to be able to optimize CO2, we need to understand other impact categories as well. What this brings to my own conclusion, and what I'm now dedicating my life from morning to late nights, is trying to bring science-based comparable understanding on the net impact of companies. What it looks like today, this is a huge project. We are only 5 years into it, at least 5 years to go to get to a certain level. But where we are today is basically, this is now a screenshot from the upright model. What we basically aim to do is summarize on the left-hand side the negative impacts that a company has on the surrounding world, taking into account the whole value chain, not just what happens inside the walls of the company, but also what happens in its value chain. Which are the players without which the company cannot produce its products and services? What can be tweaked there if you change that value chain, if you challenge that value chain? And then on the right-hand side, what are the positive values because of which, due to which the company exists? So not even the most evil oil companies that you could think of exist to cause emissions. No, they exist to power the society. There are reasons, the values that the companies are creating. And whenever we are looking at the negative impacts, we should always put them in the context of the value. Otherwise, we cannot be making fact-based decisions. We cannot think that the IT consulting company whose emissions are more modest than, let's say, the most ambitious green energy companies, that they are somehow better for not causing more emissions. Their impact on the right-hand side is completely different, and it should always be put in the context of what is the positive value created. I can see that I've basically used almost all of my time, and I want to save some time for the great discussion. So I'm going to leave you with this picture today. Would love to talk about the methodology of how this actually made. Just put it in short. What we use is basically we have built a neural network that, and actually a couple of separate neural networks that help us summarize huge amounts of scientific knowledge and attribute them to real-life products and services. And with that, build a huge simulation of the global sector, which allows us then to quantify the net impact of companies and investments by allocating these impacts in the private sector simulation. But more about that probably in the discussion. Thank you so much and look forward to discussing more.
Thank you, Annu, and thank you all. We start with the panel discussion now. We heard 4 very different angles to a topic of green transition. We heard 2 kind of rather big perspective analysis of the situation from Markku and Annu from different angles, and we heard 2 sort of very engineering, technological, innovation type of attempts to make solutions. And I think this is a good combo to have this discussion. What I like most is that I heard some key words in the discussion. I heard a keyword of science-based. I like to hear this when discussing about the solution of problems. We heard big data. We heard open data. We heard AI. So we heard a lot of critical terms in terms of doing this together. I think these are kind of background elements to make this work. By saying this, I would like to give a chance to the panelists in the very beginning to maybe react to each other's presentations. So if you have any comments or reactions to each other's presentations, you are welcome to present them. How do you feel?
I can go. I can go first. I think for me, kind of at least one of the common feels is that the there is not one silver bullet. I think it was said several times. So we all have, coming from different angles, you see also that solving the same problem is not one solution to it. And I think that's the overall. I still do believe that I'm as an engineer, I like to say the science-based, I like the facts, I like but also the short-term versus the long-term. And I feel in many of these discussions dealing with long-term ambitions, we also need to have short-term targets. And I think that is the balance we have to find. Looking at your curve, so when do we get carbon neutrality? It's easy to say, okay, 23 years, but it sounds a long way from now, and it means that actions has to be taken today and this year. And I think there is my kind of impatient in the whole situation. So I would I'd like to hear more also about your net impact. I still is kind of, if everybody's cleaning their own house first, if everybody says we want to be carbon neutral, as ABB as company I represent, if everybody do that and clean their own house, at least when we would make a big impact. If you do that in even a few years, you would make a big impact of the overall. So I hope for me, it's kind of important that we are able to find this balance, that act now and do specific and concrete actions in your own operations, in your own house. And then, of course, yes, you have to address everything else outside. But it's this risk that we can say that we're taking too much of this forward-looking that, yeah, we will fix it by 2050, but then, and there are lots of action that has to be taken later. I'm more the impatient that we have to act now. So that would be, but I think there was a balance in what we heard.
Annu.
Yeah, thanks, Morten, for bringing that up. And maybe if I comment on that directly, I fully agree with you that every company simply needs to have a lot of sense of urgency and first like cleaning everything they can inside their house. And I fully support that comment. However, why I don't think it's alone enough is that if the change that is required from the global private sector, from global industries in general, would be enough for everybody to incrementally improve what they're doing, that would be very correct. However, I'm afraid looking at whether it's Professor Kulmala's or any other calculations and any others that I've been able to do as an engineer and with the help of many international research groups, there will be entire industries that will be challenged. I'm going to take a very naive example, the tobacco industry. Is it enough that they just clean a little bit their emissions? Is it enough that sugar-sweetened soft drink manufacturers just clean a little bit up their emissions? I fully believe your point, and given the industry where you work in, definitely that makes a lot of sense to always start from inside. Before you've done the hygiene level work in your own company, you don't even have kind of like a license to talk, if I'm being a bit provocative. But that is not enough. And that's why I believe this kind of value chain, holistic, and there's also the problem of if you go very, very deep into only judging companies based on their internal emissions, that leads to really weird incentives, for example, with legal structures, maybe cutting out the part that doesn't look good, splitting companies, and we all know that is bringing the environment and the global situation nowhere. So that's why I would love to rather make it even feel a bit unfair that you are in charge of someone else that's in your backyard and not in your house, rather than having the because that really pushes to innovation. That really pushes you to decide to cut through completely change your supply chain, completely change the industry you're serving. There's a lot of professional services companies that can do a lot in terms of let's say marketing, for example. Are you helping to market tobacco? Are you helping to market electric vehicles? What are you helping to market? And I guess that's why I'm pushing for the value chain end-to-end thinking. But you are right in terms of first starting with your own house, definitely.
Markku.
Yeah, thanks. I actually have plenty of questions, and that's why I'm not going to ask all of them. First, all comments. First of all, I like a lot Annu's approach, since I think that we need this kind of from end to end, the whole value chain to look at. And actually, I can even say that I started my career as a scientist making my master thesis on that topic in '82. And 1900, not 1800. I'm more or less I have been waiting that somebody else is doing this also in this kind of comprehensive way, and I'm very happy to see it. And actually, I would like to go in details about your algorithm, that what you have there, and what I had in that time. And also, this is very important to look at what is the good side, the positive side of this value chain, not only negative side. We need energy, we need food, we need water supply, we need medicine, etc. And this is very important thing. This is one comment. And second comment is to Peter. You saw very nicely that in 2040, if you look this kind of estimations, what we have today, you have still a big fraction of fossil fuel. And 2040 is less than 20 years. And are we really able to use this much of things, this amount of oil in transport? Or what we are using oil? We might need it somewhere else more importantly than in transport. And then, of course, electricity. Electricity is very good solution in many things, but maybe not in everything. We need also to look this, and that's why what I typically say that this kind of observations is it is must. We need to know these things, but it's not enough. We need also to look that we are not counting everything 2 times or 3 times or 10 times. That what doesn't help, but very good and very interesting points, which I really like to see your viewpoints.
I think typically when somebody is presenting their own topic, they talk about what they know and how well it goes, or what is the sort of the positive perspective. But we all know that there are these unknowns and there are these unknowns also in the background. And Peter, I would like to ask you maybe a comment, maybe related to what Markku was talking, that you are focusing a certain type of fuels catalog or production family, and you mentioned hydrogen as one part of that, and that's kind of an interesting, because everybody's talking about that, but what is the real situation right now? What do we not know, or is there a future in near future for H2?
Yeah, it's indeed a very hot topic at the moment, and there is a lot of excitement around hydrogen, and of course I am also very excited about hydrogen. Having said that, there are of course still a lot of things that need to be developed in order to get the cost efficiency and the scalability on the right level. So if we start first from the production of hydrogen, it's all about the carbon neutral or even green electricity. And the price and the scale of available sources for that green electricity has of course to be developed immensely before if we want to have a true hydrogen economy, for instance, in the whole of Europe alone. The second part is then the electrolyzer development. So there are several different technologies on electrolyzers. There also I see still there is plenty to do to develop the efficiency of those systems, and especially the operability in different kinds of electricity sourcing. So to be on that side, I would say that for Europe, there is very difficult to see that hydrogen economy would be a big opportunity without nuclear power, because hydropower is not sufficiently available all over Europe. So we must see, on top of the renewable sources like wind, solar, of course also other carbon neutral sources which bring stability to electricity production. Then what comes to the usage, the first phase where also Neste now is already looking at potential to invest into green hydrogen production in our Porvoo refinery site is really to use it captively in industries to replace the fossil hydrogen, the grey hydrogen, with the green hydrogen, to make the value of the products and the sustainability content of the products higher. it could be also the steel industry, for instance. As we know, there are big projects there as well. So industrial applications first, and in the next phase, yes, there will be, once the logistics is there will for sure also be a market as a fuel for hydrogen. So, but it's a little bit a longer story. But it's an exciting area.
Very good. I think this is something we all follow very much at the moment. I'm happy to see also development, or specifically development here in Finland in terms of this technology.
If I could add to that, I think also I agree. I would see the change of hydrogen today. When you look at, we will not replace. I mean, it takes time to replace first the coal-powered electricity power generation, and therefore that is what needs to happen first. I think that so we will not use renewable energy to produce green hydrogen, as you say. You will have to create. We need to replace brown coal-fired power plants with renewable energy. That's kind of, and unfortunately, what has happened in Europe is that we have replaced the nuclear power plants, like in Germany. We have replaced those now again with coal. So a lot of the renewable power generation that has happened across Europe over the last 10 years has been going to replace nuclear power instead of replacing coal power. So there is quite a long step now to come that we have enough energy to produce hydrogen. There are many areas where it will be a very good, green hydrogen will be a very good alternative longer term. But if you talk about the next, I would say 10 years, maybe you can argue about this will not have a major impact. But we have to do the innovation and the technology development now. So there is at the time we have enough renewable energy. But again, it comes back to what I was trying to say earlier, kind of this short-term impact versus the long-term impact. And we need the short-term. For me, again, it's about how we reduce carbon emissions. It's about replacing coal power generation of electricity instead of, so we cannot afford using it for hydrogen yet. That will have to be a second step.
In terms of short-term and long-term, it's very interesting to think about something like year 2030, 2035 or so, when many of us is claiming to be carbon neutral. What is your reaction based on what you know and what you know from your experience and field? Are we on a right track? I mean, are we on a track to potentially do that if we do our best? Is there any chance any longer? I'm a bit skeptical as you hear. Markku.
Yeah, this is, I hope that this is really not only wishful thinking. It's always good that people think their emissions and try to understand the whole value chain. This is always good if they are really doing it, companies or people or cities or states or different kind of, but if it's done in the way that you get your emissions down, you can never get them zero. This is impossible in practice or even in principle. And then you need to get some way to get the CO2 out and all other greenhouse gases and other which affect on our climate. And this is very hard. You can have your own forest where you can try to do it in some way, or something else, or some technology where you can do it. I hope that ABB can do it in technological somewhere in 2035 or so, in real numbers. But then people, very many people are thinking that yes, let's compensate. But how do you compensate? If I'm compensating his emissions and his mine, it's zero effect in a climate point of view. And that's why, on the other hand, I know that we need to do this kind of thinking, and we need to go this way that we are thinking really our value chain and our emissions. And also thinking that are we able to take CO2 or methane or whatever out from the atmosphere. But then if we are not thinking and if we only use hand-waving ways to compensate, then it's not good at all. And although I saw this picture that if we are getting emissions down globally 2% and things up 2%, I think that it's very hard, and I do not see any hint today that it's really happening. But I'm that wishful thinker also, that I hope that we are getting it into this 23.
No, Peter.
Maybe a comment. I think it might be very challenging from the global perspective, but company-wise, of course, like for instance, Neste has a clear target to become carbon neutral in production in 35, and we have actually a roadmap for instance, the Porvoo refinery with time to really replace the fossil feedstocks with circular economy and bio feedstocks, and also by converting that we can also generate some renewable gases that we then can reuse also even for hydrogen production. So there is this kind of a full picture, and with calculations on scope 1 and 2 and scope 3 as well we have been doing. So to understand really that how to get there. So I think it is possible, but does every company do it at the moment? Maybe not.
But this really leads to an interesting discussion whether these sort of nationwide European or global agreements, negotiations are enough, or is it more that the businesses are committed to do that and they actually do that? And if many enough are doing it, the track is there. But Annu?
Yeah, I guess we only have one planet, and no matter where we work, we are dealing with the same issues. So that's why I'm really concentrated on global solutions. I think one thing here that I'm an optimist, and I think that's kind of like I don't think we can afford to think. But kind of like to forecast whether or not we can still save the situation. We have to do our utmost everything to now fix the situation. I think one thing that I do want to raise an optimistic point about where I see a lot of potential, which is the amount of bandwidth today, both from companies, executives, investors, but also public sector regulators. We talk a lot with the EU, obviously they're doing a lot of regulations that also impact how impact needs to be measured and so on, is still today like 80% of that focus is going to things that are in the end of the day so teeny tiny that they don't almost matter in the big picture compared to the couple of relevant questions. And I believe that if we can bridge the gap between science, kind of like what we know and what we practice, if I'm being a bit crude, science and business, even though I'm on the business side now myself, but kind of like if we can really bridge that gap with simple enough explanations showing what the science is really saying, because the solutions are there. It is not that complex to understand the difference between I loved your example of an escalator and a set of stairs. From a net impact perspective, I guess we all know what makes sense for people's, of course, as long as people are able to walk and so on and are able to climb the stairs. But if we are able to bring some science to what is big and what is not, and instead of the 20%, use 100% of that brain power, willpower, capital, resources, innovations on actually those impacts that are the largest, I do believe we still have a chance. But we need to have then the kind of like the, and that's why I spend my days as I do, and just trying to explain what is big and what is not. Realistically, a company executive making big decisions, and not just on green transition, but keeping the company alive, being able to employ people, just not going bankrupt. Realistically, as a company executive, as a board, you can think about 3 of your biggest negative impacts and 3 of your biggest positive impacts. And I think this is the level where you should be at, and then be able to use this as a guiding thought, that these are the 3 main categories of value that we create. These are the main negative impacts that we need to everyday work on making smaller and smaller, and that brings your net impact to a more positive direction. And then you will be able to concentrate your resources on that and not concentrate on the 360 different projects that you don't quite understand how they link somehow all to the same equation. And this is simply needed because we as humans are limited in our brain power to think, whether we are politicians or business women or whoever. We need to have some simplicity to the scales of impact, the scale of different impacts. And I see a lot of potential there.
I hear your long explanations, and but still I want to ask you one more question. Do you think that we have data enough to do this impact analysis? I mean, the example you showed on the soft drinks and medicine. How do you compare the health impact to CO2 emission impact? Do you have a concept, or do we have data which is there just to be used, or do we still need to make the data comparable data? How do you see that?
If the question is the science perfect on all the impacts? No, and it never will be. We will never have perfect data on innovations that are not even out yet, that haven't been studied. My practical question here as an engineer is what we are basing our decisions on today versus what would be available in science. It has been available already for decades. We're not even reliant on the latest science of the last year, even though that is also really exciting. But using even like 10-year-old science to guide decision making already brings us to such a more better stance than what is decision based on today. Decisions today are often, if you think about this kind of like net value creation equation for a company and what is being used, we typically used to thinking there's like jobs and taxes, and that's what we're looking at. There is so much more that can be utilized in scientific consensus alone, and that is of course a subset of things. There's a lot of things the scientific world is not yet agreeing on, but already just utilizing the part where it says consensus. You mentioned like the soft drinks, for example. There is scientific consensus. We, for example, use a lot of things in the World Health Organization, how they have been classifying different diseases based on disability-adjusted life years, these DALY indicators. All diseases are not equal in terms of how much disability-adjusted life years they cause on the global population. All medications are not equal in terms of how they treat and prevent diseases and what is the human cost or the environmental cost or so on. This information can be utilized, and I think as an engineer they should be utilized. We have been like accumulating that information on public funding, private funding, whatnot. We should be using that in our decision making. So to your question, is the science perfect? Is the information impact perfect? No, I would not be working on this if it was already perfect. But I think it is our duty as humanity to use the information we have already spent the scientific resources on to better guide our decision making.
Morten.
Yeah, but to answer your specifically on your question, will carbon neutrality happen? I think, for me at least, asking about are we on the right track on some of Anna's point you had there, is it clear targets in large corporations today? Yes. Will we make it in every country? I mean, clearly no. But I think for me, I always argue also, there is always easy to say, why do we have to do something? Because look over there. And that kind of excuse will definitely get us nowhere. So we have to, I think here also businesses needs to take the lead. As I say, that we have in large corporations, there is clear commitment and clear targets when it comes to carbon emission reduction. ABB, for one, we have published like 2030. I know that internally we see that probably will be 2026. We are not the biggest emitter, but at least I say that first you need to clean our own house and our own garden. And then the next step is what's the signal that we would give out to suppliers? Because if all of our suppliers and their suppliers again get the same message, I mean, then we are back to it needs to follow through the whole value chain, and that we are using the best practices. We have what we call mission to zero units, and we have one here outside Helsinki in Porvoo, where I was yesterday morning to visit the team, and how they've been able to get this already now as zero or carbon neutral operation, not by buying credits, but by installing solar panels. So they're able to get. They also have geothermal, and have been able to reuse then the wasted here because they have heat and a lot of machinery, and they reuse that heat also for their building, but even for storage during with the geothermal. So it's like a large battery in the ground there. So a lot of good examples that has been used, and then it's to copy those examples to everything inside what we do at ABB, but also to all our suppliers and our customers, because everybody, all big businesses, and you talked about the C-suite engagement, which I can confirm, at least at our company, but also in most companies today are there. It impacts incentives, the bonuses for management, for myself included. So it's part of, this is what we all have to do to not just drive performance of a company, but also to develop and to drive the sustainability journey. This goes hand in hand, and you don't get one without the other. So I think for me that is the answer to the question is yes, the commitment in there. The targets are in place, the plans are also in place, the execution is happening. But there, I'm coming back to this, I want to see actions now and what we do, and that we don't start too much of talking about, why do we have to do it? We can look at US, look at India. There are countries where we still have big opportunities for efficiency, but we see the same trend is happening. It's just on different parts of the curve. So I'm confident that we will see it also across the world. So we kind of use technology and be optimistic that the rest will follow. Somebody have to take the lead.
Thank you. You all make me feel very, very positive now. But I still have to ask Markku about the global situation. If we want to be aware of the status of the climate and global weather system and so on, we need observations all around the globe. And we see the problem in going to Russia and get data from there. It's a big land area, very important land area. What about China? What about US, India, Brazil? How do you see globally? Do we have a sort of joint effort to work with the big players now?
Yeah, thanks. This is very good and important questions. First of all, I would like to say that we get some part of the big picture, of course, from satellite data. But we still need this kind of in situ ground-based data. And for example, we had observations in Siberia, but the data coming ends 24th of February this year. And of course, right now, I don't know exactly. China is they are investing this kind of observations, and they have pretty good observatories. They are very keen on their air quality problems, and there is anyhow 2-3 million people dying every year due to bad air quality there. And then US is also, they have enough resources, but so far they are not putting, it's too fragmented what is this US situation today. India, Brazil, they have started to have some ideas about this kind of collaborations. South Africa, we have these kind of observations. Of course, the World Meteorological Organization has their own basic weather observations, and with satellite data this can be covered, but this kind of climate change related specialities are not that clear yet, and this kind of open data is certainly needed, and this concept what I am promoting and what I have developed, it's one of the key of those. I would also like to say something, is I'm very happy to see during the last 10-20 years that how big companies are really working here. And if you think about emissions, if we use this technology, which is typically used in Finland or Nordic countries, the global emissions would be only 60% of the present day emissions. If globally would be used this kind of thing, then it would be almost carbon neutral. Almost. But how we get it that it is used in global economy, that not using this kind of a little bit old style systems. And I do not mean, when I speak about best possible technology, I do not mean 1 per mil. I mean something like 10% technology, the best one. And this would make a big sense, and this can be possible. This is somehow possible within 20 years to start to use this kind of technology. But we need once again understand the value chain, and there is still a lot of solutions what we do not know yet.
Thank you. Now I look at the audience, and I give the first question to the gentleman over there. Can we get the microphone to him? Wait for the mic. And please raise your hand if you want to make a comment or question.
Thank you very much, and for all the panelists, this has been extremely interesting to listen to. I am Ville Voipio, Chairman of Board of Vaisala, and first of all I'd like to comment on what Professor Kulmala said about the observations, because actually our business is to sell that observation technology all around the world, and you're actually right, the image looks the same from our point of view. We have the common atmosphere, but the amount of observations we have is very unevenly distributed all over the globe. And there are natural reasons. Okay, we can't do anything about the geopolitical reasons, but then we have like Africa, which has very few observation points in any atmospheric observations, and that's because they don't have the funds to do that. Right, and we're not talking about like 1% of GDP of the world. We are talking about 0.000 something % of the GDP of the world. So I think this is something that is highly neglected also in the international setting. But actually my question, and now I'll switch my hat because I know our communications department is here. So from now on, I'm a professor of practice of sustainable global business from Turku University. And in that capacity, my problem is to see how the world looks in 20 years. So how are we going to solve these problems? I know we have a lot of tools, but my feeling is that I'm building a house, and I have a collection of tools, I have a collection of materials, very miscellaneous tools, very miscellaneous materials. I hear that Neste wants to use the lignocellulose for producing biofuels, and I understand that Professor Kulmala wants to use the wood in the forest to use it as a carbon sink. So we have a lot of problems like these, and I can't see the big picture. I haven't seen the big picture. I can see that we are sectorally solving the problems, but where is the big picture of the world in 2040 or 2050?
Kind of a main question. Do we have an answer in the panelist? Or any comment to this? I mean, it's a tough question.
We need all of those in different sectors, and of course we cannot be in silos. We need to work over sectors. This is one question. I think that all these things what we have heard today, for example, and other day, we need all of those, and that's why we need carbon sink, we need solar power, we need understanding the whole we need electricity, we need this extra power things and all these. We need all of those, and I hope that our understanding is totally different level in 20s, but it doesn't help you when you are now building your house. That after 20 years we are at other level.
But I think Annu's approach is sort of approaching this question. If you put all the impacts on the pool and you start solving the issue, you get sort of, you can optimize the system also in many different ways.
Yeah, I guess the question was also about the building blocks, and I cannot other than echo what Professor Kulmala said about. I know it's super overwhelming. I can totally feel where you're coming from, and it is exactly as complex as it feels. We cannot afford to let any of the tools go, and as tempting as it would be to say that this is not a solution, let's just all do that. Where my solution can help, where I try to contribute, is basically understanding the big picture, being able to understand what are the biggest things to concentrate on, and being able to maybe leave the rest, the long tail, even unattended, which may sound a bit provocative, for a while, to be able to concentrate on the biggest things. But I think there is no silver bullet to the answer, and I think more the question is being able to put enough resources, enough bandwidth, and enough of the analytical minds, both in business, private sector, public sector, to just like really put effort into it.
There is one question in the front row here. Wait for the microphone.
So thank you for your insightful discussions and presentations. You talk about measuring net impact and finding the biggest positives and the biggest negatives. You haven't mentioned the war in Europe. Mm-hmm. So what do you think about this? Is this a huge net positive or a huge net negative? It makes us focus on fossil fuels and getting rid of them. At the same time, Russian oil and gas flows to the east, and it's hard for Poland and Estonia and other countries to get rid of coal. So should we not care about this since we cannot influence it directly, or is this one of the bigger problems? Will it just disappear by itself, or should we be seriously worried? Thank you.
This is a good question. I mean, is disruption a tool here and now for the green transition? Accelerating the transition in a way. Mm. How do you respond?
I may go first. I think the war in Europe or war in Ukraine, as we see now, I mean, it has shown these both the uncertainty about energy, and then it's always a question, will it speed up or will it slow down the green transition? And I think it will speed up, because but there, of course, there is also a risk here of that we're all kind of going back in our own caves, so to say, that we're building more, we're getting more isolated because we want to be independent and take. But so here again, it's a balance that you need to have a kind of national security, national supply on one side, but you cannot do everything by yourself. So, and this is the very tricky, there is not one simple answer to it, but I kind of, on a high level, I say that I think it will rather speed up the green transition. It shows now the importance of our energy and our whole setup of supply chain, and it will drive more of local and regional power generation. You cannot depend always on something far away, so you need to take more responsibility locally as well. More of local, it's not microgrid as such, but it is more of local self-sufficiency that has to be there. So I think that will be an outplay. And the other part is we're looking at, it's not just the war in Ukraine, but all the macroeconomic trends that is happening, with trade barriers between regions, will also lead to more of, which maybe we end up in a place where we end up in more of regional supply chain, which may become more expensive. It is not because you don't get the same scale, but it will reduce the transportation, and so we need also to have a higher price on transportation. I believe that will balance some of it. So that may be more of a positive outtake of what is happening now. I'm looking at the long term.
Yeah, Peter.
Yeah, I think of course, it's obvious for everybody that it has speeded up already the energy transition. So to getting out of the Russian energy base. Now the question whether it's also speeding up the green transition, I think that depends on certain things. So like if we talk about the Maslow pyramid and people's access to food and heat in their homes, that's of course the first thing. So it depends a little bit shorter term, what will the economy look like in Europe? And hopefully it will be strong enough that it will then I agree that it will speed up the green transition as well. But then again, coming back to the EU regulators, make sure that it's easy to implement the green transition, and let's not make it too difficult.
Yeah. And that, can I also just say, I think that is always the comment, always there to be clear about the intention and the direction where we want to go, but not always so descriptive of how do we get there. I think that is really the key to the politicians that are listening, that we kind of let's agree about the direction and the end point, and give freedom to industry, also see how do we get there. Then we can use technology and the good and working together across industries to make it happen.
Last comment, Markku.
Yeah, thanks. To add these few points, which I agree, in short term, I think that it's very negative in very many ways, at least globally and also in European. In a longer run, it could be have these benefits, what you said. Then is a question that if this situation continues very, very long, it means that we do not get data. And which means that if we do not get data, let's say 10, 20 years from Russia and maybe some other countries also, then it has been done. We have very hard time then to improve these kind of things in climate point of view, and that's why it's also very dangerous and negative. The green transition in Western countries or Europe and a couple of others, it's of course good, but still we are only very small fraction of the globe. But
Thank you, Markku.
Thanks.
This was a good ending point of the discussion. I'd like to thank all the audience and of course our great speakers, so let's give a big hand for them.
Right. Thank you all, and thank you, Professor Hämeri, for running a very tight ship. I don't know what you told everyone backstage, but the talks, one of them was a minute and a half short, one of them was to the second. If anyone is doing any conference planning, Kaarle has the secret. Right. I would also like to thank our viewers who are watching the events in Singapore with our forum partner Neste, and the viewers in Kuala Lumpur with our partner Halton. Before I let you go for a nice long break and lots of networking and food, a couple of housekeeping items. One is that in the interim, we're going to have a couple of events in here during the lunch break, so if I could kindly ask you to make your way out into the foyer. The second thing is what you'll find when you get there. In about 15 minutes, we're going to have the start of the Millennium Graduate Student Contest. I mentioned today that we're going to have another prize given today. So passionate young innovators are basically going to be giving lightning talks, 3-minute pitches about their work. There are 5 finalists. There will be 3 winners. We'll be talking about the winners later. The work ranges from microalgae to optimized decision-making to high-performance batteries. We will be meeting at least 3 of them later. And for now, there is only one thing left to do, which is to say, enjoy your lunch. Thank you very much indeed. Great stuff.